Hi everybody. We're going to talk about division today, and I just want to specifically talk about the topics that I'm going to be covering. So we're going to talk about writing and modeling story problems for division with and without remainders. We're going to explain the standard long division algorithm along with some non-standard methods. We're just going to talk about the scaffold method and how it really is the same thing as the standard long division algorithm. We're going to talk about writing, solving fraction division story problems, why we invert and multiply, why that works, and why we move the decimal place when we divide decimals. And of course, throughout all of this, we always want to be thinking about the Common Core math practices. Specifically, we really like to focus on 1, 3, and 6, which are our make sense of problems and persevere in solving them, constructing viable arguments, and critiquing the reasoning of others. That's sort of that justification, justify your reasoning, why do we do things, and also attending to precision. So let's start here with just what is division. Division, of course, could be modeled by A divided by B, and an example of A being a number of objects and B is the number in each group. So this is the how many in each group example. Or we could also have a how many groups example, where A is a number of objects and B is the number of groups. Okay, so now let's talk about what makes sense when we divide, because sometimes when we divide we use remainders, and sometimes when we divide we use decimals, and sometimes when we divide we have to make sense of our answer and give a logical estimate based on our answer. So let's talk about that. So first of all, up here I have 23 divided by 4, and in this first example we're going to be thinking of this as 23 apples divided by 4, because we're going to put those apples into 4 groups. And so our question is, how many apples then, if we have 4 groups, how many apples will belong into each group? So what we could do is, we know that we end up with 5 with a remainder of 3. In this case, we could interpret this as each group gets 5 apples and then there are 3 apples left over. Or we could write our answer as 5 and 3/4. So a lot of times we write our answer as a fraction by dividing our remainder by our number of groups in this case. So 5 and 3/4, which means we could take every group gets 5 apples, and then every group gets 3/4 of another apple. So we'd have to take the apples and divide them up into fourths, and then give every group 3 of those fourths. So that certainly makes sense if we're talking about apples, because we can actually cut apart apples, and it makes sense to do that and continue to divide them up. Sometimes we might think of this as the next logical answer. In this case, it might be how many apples in each group. It's not equal to 6. 5 remainder 3 isn't equal to 6, but we could say, well, just 5. In fact, let me write that here. Just 5 apples in each group if we don't want to have any remainders left over. In this case, let's think about boats as another example, and number per boat. So instead of the number of groups, we're going to talk about the number per boat. So we have 5 remainder 3, which would mean 5 people per boat, and then remainder 3. So that means that there are 3 from those 23 students that don't have a boat, 5 in each boat with a remainder of 3. We can also think of our answer as a decimal, which in this case doesn't make sense, because you wouldn't have 3/4 or 75/100 of a person. And so how many people can go into each boat? In this case, it makes the most sense just to say 5. Okay, so now let's talk about the standard algorithm for long division, and also the scaffold method, and really how those two go together. So this is the standard algorithm, and a lot of times the way that we learned it in school was we would ask ourselves, how many 8s go into 5? Well, 8 doesn't go into 5. But it's really not 5, and so I just want us to remind ourselves this is 5,000, and that's what that 5 represents. And what I like about the scaffold method is that it gives basically reason to our decimal system and our place value. So in our standard algorithm, then we would go to the next place value, and we would say how many 8s are in 50, and then we would, of course, divide, multiply, subtract, and so on, and we would end up with 634. When we do the scaffold method, what we're doing is we're really showing what this means in terms of this. And so when we put a 6 here, it's not a 6 per se, it's actually 600. So we're going to write it as 600. And what that means is that if we're dividing 5,072 of some number of or some object, say those are rocks, into 8 groups, then what that means is that we're putting 600 into each group. And we can't take any other hundreds. This is as far as we can go in hundreds. So you can see that left over, we still have 272. But those aren't enough hundreds to split among 8 groups. So now that we're done splitting up our hundreds, now we're going to split up our tens. And that's where we get our 30. So here we just write it as a 3, but remember it's not a 3, it's a 30. And that's what that means. So 30 means that now we have enough in tens that we can put 10 or 3 groups of 10 into each group. So 30 goes into each of that 8 groups. And when we do that, we end up with 32 rocks left over, which will allow us to then put 4 more rocks into each group. And then we don't have any left over. So we can just quickly put our answer together. 600 plus 30 plus 4 is 634. This is also sometimes called partial quotient division, and as well as scaffold long division. Okay, and lastly, I guess not lastly, but almost lastly, we're going to talk about fraction division. And so, first of all, let's just make sense of what this might mean. There aren't really that many great examples of dividing fractions in the real world. There really aren't. I mean, there are some, and so here's one. A lot of times it's cooking related. So, in this example, I have 8/3 cups of popcorn. So I know that for 1 popcorn ball, I need 2/3 of a cup of popcorn. So I'm wondering how many 2/3 are in 8/3. In other words, how many popcorn balls can I make with the amount of popcorn that I have? We can visually show that here by taking our 8/3, which of course is 2 2/3, and we're going to see how many 2/3 are in 8/3. So you can see I have 4 2/3 in 8/3. So now let's just talk about why do we invert and multiply. And the thing that's interesting about the invert and multiply algorithm, that rule, we learned, and I remember learning it in school as a rule that applies to division of fractions. But really it doesn't. It applies to division of, division. That's what we do when we divide. For example, look at this one, 3 divided by 4. We can write this as 3 divided by 4 as a fraction, 3/4. We can also think of this as 3 times a 4th. And if we think of 3 divided by 4 as taking 1/4 of 3, that's really what we're doing when we invert and multiply. We're thinking of it in that taking a portion of another number method. So if we take 2/3 divided by 1/2 then, so let's turn both of these into a fraction, 2/3 divided by 1/2, then I'm going to write this as a complex fraction here, 2/3 divided by 1/2. And so then I can just do the same thing I did before. I can just think of this as 2/3 times, how many parts am I taking here? I'm taking, in this case, I was taking 1/4 of that number. In this case, I'm taking 2 because my 1/2 is my denominator, so I'm taking 2 of that. So really, it's just a shortcut. That's what the invert and multiply is. It's not a fancy surprise magic algorithm. It's just simply a shortcut to doing what we would do otherwise. Okay, and lastly, I'm just going to briefly talk about dividing decimals. Dividing decimals, the algorithm is to move the decimal point a certain number of places in both of your numbers. So in other words, if you move the decimal point 2 places here, then you have to move the decimal point 2 places here. Well, why do we do that? It's quite simple, because really all we're doing is replacing the problem. So here we have, in my example, I have the cost of plums per pound is $1.27. And I have $4.50 in my wallet. And so I want to know, since I have $4.50 to spend, and plums are $1.27, then how many pounds of plums can I buy? So it's a simple division problem. I'm moving the decimal point 2 places here, and I'm moving it 2 places here because I just want to replace the problem by multiplying both of my numbers here by 100. When I multiply $1.27 by 100, I end up with 127. And when I multiply $4.50 by 100, I end up with 450. So just by replacing the problem, I end up with an identical answer. So this becomes my new problem, 450 divided by 127, and I end up with my answer of 3.54 pounds of plums. Okay, that's all I have. It's a pretty straightforward chapter on division. I hope that helps, and make sure you're asking questions if you still have them. Thanks.